Alright, here's the third page of the review guide, and I'm going to go kind of quickly. How many times larger is the lap pool than the wading pool? Let's first find the area of the lap pool. Area is length times. Alright, here is the third page. How much bigger or how many times larger is the lap pool than the wading pool? They mean by area. So to find the area of the lap pool, we'll take length times width. To find the area of the wading pool, we'll take length times width. To figure out how many times bigger you are than something else, you have to use division. So I just want to divide these two. So I'm going to rewrite the area of the lap pool just by factoring x minus 4, x plus 4 times x plus 3 divided by x plus 4, x plus 4. And we can see the x plus 4's cancel. And so it is x minus 4 times x minus 3, x plus 3, sorry, all over x plus 4. Not a very pretty answer, but the division tells us that. Wading pool is x minus 4 feet deep. What's its volume? Well, here's its area. So length times width times depth. And you could leave your answer like that, or you may want to multiply that out and get some cubic equation. Either one would be fine if they don't tell you exactly what they want you to do. And then finally, if the lap pool has a certain depth, well, here's the area of the lap pool, so we'll take that. I'm going to factor that x squared minus 16 times its depth, and I'll divide that by the volume of the wading pool. And we'll just cancel, 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 and it's x plus 3 more. That's all there is to it. Next problem, we have to do a little bit of graphing. So let's go ahead and take this polynomial and factor it. Guess I better get it so I can see it here. Numerator is going to factor as x plus 3, x minus 2. Denominator, I can pull out a negative 4. X squared plus 4x plus 3, and so I can factor that denominator a little bit more. X plus 3, x minus 2, all over negative 4, x plus 1, x plus 3. And right away, I notice these are going to cancel, and that tells me where a whole is at when x is negative 3, because negative 3 makes that denominator 0, but it cancels out, so we call that a removable discontinuity. Doesn't give us an asymptote, but it does simplify. And I'm going to distribute that 4 on the bottom. Now notice in the holes here, I put down the x value, but I haven't found the y value. To find the y value, just plug that negative 3 into this equation. You get negative 5 over negative 3 times negative 4 is 12, minus 4, negative 5/8. It's a 5 right there. So there's where the hole is. And you could even plot that point at this junction. Negative 3, negative 5/8 would be somewhere around, negative 3 is going to be there. Negative 5/8 would be right about where that point is. But that's going to be a hole, so I'm going to kind of leave it with that little gap in it. So there's the hole. Going back up to this version, without the -4 distributed, I can see -1 causes the denominator to be 0. That's a vertical asymptote. So x equals -1. So back to the graph. -1's about right there. And so a vertical asymptote will be right about there. Let's see here. Horizontal asymptotes, we compare degrees. I got x to the first, so I look at coefficients. 1 on the top, -4. So y equals -1/4. Back to the graph. Y equals -1/4. Well, this is -1 right here. That's a -1/2, so -1/4. We'll run right through there. Now I have to be very careful here. Let's zoom back in. I think I had a hole at -5/8. Well, if I'm in a quarter and -5/8, it's going to have to clearly be on the other side of that. Because -5/8 is bigger in the negative direction, or smaller if you want to, than 1/4. So we're going to have to check a few points and make sure on the right side. X-intercepts and Y-intercepts are relatively easy. For x-intercepts, just look what makes the denominator 0. That's 2. So 2, 0 is an x-intercept right there. And for y-intercepts, just plug in a 0 for x. And if you plug in a 0 for x, you get -2 or -4 or a half. So I got a y-intercept and a half. Let's plug in another point for x. Now remember, our equation that we've simplified to is this. And so I might choose to, if I can erase, nope. I might choose to just plug in some xy values like -2. If I plug in -2 in for x, I get -4 on top. I get 8 minus 4 on the bottom. -4/4, I get -1. So when x is 2, y is -1. Undo that last stroke. It won't let me. So -2, -1 will be right about there. And so see this hole right here? It's got to be just on the other side of that. My curve's going to fit in there just like so. And on the top, it's going to fit in just like so. Never crossing those asymptotes. And so that's a fairly acceptable graph right there. Hopefully that helps you with part 2. But remember, and always remember this, if you have the technology, i.e. your calculator, plug that thing in, take a look at the graph, and get yourself a heads up before you even try to graph it.